Hey guys, Mr. Esposito did a great job on Friday teaching you the dilations lesson, and you guys asked such good questions, and there was good discussion, and everybody was working hard. The problem was we ran a little bit out of time, so he didn't really have as much time as he had planned to do all the examples with you. So I thought I'd just make a video and go through each and every one from the class handout, which should obviously help you with the homework worksheet. So I know you did a little bit of each one. Different classes did different ones, so I'm just going to do them all, and hopefully, if you're stuck on anything, you'll revert back to the video, and there'll be one like it on here. Okay, so I'll just start from the beginning. I'll do the whole thing, and if you have any questions, feel free to post them on the website, and even if it's a specific question from the homework worksheet, I'll help with that too. All right, so starting with the front page of the handout, I can't, I think it was a colored handout for you guys, but either way, it's the one that has these three pictures on the front. It's the one that had the vocab on it. So take that one out if you want to follow along. All right, so for the first three, the question is to determine if the transformation from figure A to figure B is a translation, a reflection, a rotation, which are all the old ones, or one of the new ones, a dilation. So let's look at this first one. From figure A to figure B, which of these transformations is it? Hopefully you said dilation, because hopefully you can see that figure A was enlarged to figure B, and dilations is the only transformation that changes size. Okay, they call that the similarity transformation. Okay, where the other ones were congruence transformations. These two figures are not congruent, but they are similar. So this is a dilation. How about this one? Okay, hopefully you said reflection. Notice the size and the shape are the same. The only difference is the orientation. So it looks like it reflected over the y-axis. So that's a reflection. And this one? Okay, again, excuse me, same size and shape. The only difference is it looks like it slid over and down, which is a translation. Okay? All right, so that's the first set of problems. If we go to the ones on the bottom here, I think you did this one in class. I can't remember for sure which periods did, but I think this might have been one where everybody did it, but I'll go over it again. We're going from figure A to figure B, and we have to determine is it a reduction or an enlargement. Okay? Figure A to figure B, it started as this size, 6 by 3, and it changed to 2 by unknown, right? And that's something we're going to have to figure out after. But it looks like this is clearly a reduction because the figure got smaller. So basically all you have to say. So this is a reduction. All right, now we have to find the values of the variables. So you can set up a proportion. I think in class a lot of people just did this in their head because the numbers were pretty basic. But the idea here is if you want to always get it right, just match up the corresponding parts and set up a proportion. Okay? If I'm going to start with A and go to B, then my proportion would be 6 goes with 2 as, and then just pick a side. What do you want to do next? You want to do X? So 6 goes with 2 as 3, which is corresponding to the X. Cross multiply, 6x equals 6, so X equals 1, so X equals 1. And you can do the same exact thing to get Z. In fact, it's a rectangle, so those opposite sides are going to be the same, so that's 1. And actually, you can sort of cheat and get that Y value the same way. But just for the fun of it, let's set up another proportion to solve for Y. All right, so 6 over 2, right? 6 goes with 2 as 6 goes with Y. And here it's even more obvious that the Y has to be 2. But again, you can always cross multiply if you're ever not sure, and you'll get the right answer every time. Okay? All right, let's do number 5. We're going from figure A to figure B. So this one is an enlargement. Okay? And let's solve for M and N. So let's see. The 14 is the only number I know on figure B, and that matches up with 7. So I'll go from A to B. So I'll go 7 to 14 equals, and I'll go with M first. So 7, or I'll solve for M first. So 7 goes with 14 as 8 goes with M. And now we can solve. So 7M equals 80, 32, 112, I think. So M equals, excuse me, M equals 1, 6. If I did the arithmetic right. You can double check me in the calculator, but I think that's okay. So actually, I'm sure some of you already got 16 because I just realized 7 to 14 is basically 1 to 2 if we simplified. So 1 to 2 would be 8 to 16. Okay, I just was so focused on doing a proportion because I know some people are still having trouble setting these up, and I wanted to make sure you can do that. It's nice when the numbers work out so evenly, but it's not always the case. How about n? Let's see. So 7 over 14 equals 10 goes with n. So that's going to be 7n equals 140. So n equals 20. And there's your variables. All right. So that should take care of these types of problems. If we go to the next page, now we've got the ones that have the coordinates. So let's do a couple of those. And let's see. This time, the coordinates are given, and they're giving us the scale factor. So this is the scale factor. And the scale factor is basically telling us, just like you did in class when you drew it with all the rays and everything, the scale factor is telling us what to do to the original problem, the original figure, to end up with the new one. So how do we go from the pre-image to the image is what the scale factor tells us how to do it. The scale factor tells us how to go from the pre-image to the image. So if the pre-image is PQR, P, negative 2, 3, that's P. Q is 2, 1, Q. And R is negative 2, negative 2. The scale factor says take all of those coordinates and apply a 2. Apply a scale factor of 2, which in other terms is basically saying double it. Right? If you multiply by 2, you're doubling. So if P started at negative 2, 3, then P prime is going to be negative 4, 6. You literally take each coordinate and multiply by that scale factor. Negative 4, here I'll do a different color. Negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 is here. That's P prime. Yeah, I could have done that red also, but here, Q prime is going to be 4, 2. 1, 2, 3, 4, 1, 2. That's Q prime. And R prime is going to be negative 4, negative 4. 1, 2, 3, 4. Oops. Yeah, 1, 2, 3, 4. 1, 2, 3, 4. Here's R prime. So here is your image. Okay? So again, the scale factor tells you exactly what to do to the original, and you just apply that to each and every point, each and every coordinate for each point to get your new one. I should have used a ruler here. It doesn't look so good, but the coordinates are correct. All right, how about this one? Numbers aren't so nice, but you know what? It's the same concept. 0, 4, 2, 1, negative 4, 2. Apply a scale factor of 3 halves. What might be easier if you want, if you're having a little trouble with the fraction part of it, you could rewrite this as 1.5. But, you know, 1 1/2, 3 halves, 1.5, they're all the same thing. They'll get you the same results. It's just a matter of applying it to each and every point. So this, obviously 0 goes to 0. 4, when you multiply by 1 1/2, actually gets you to 6. And that's P prime. Q prime, if I multiply by 1 1/2, I'm going to get 3. And if I multiply by 1 1/2, I'm going to get 1.5, or 3 halves again. And then R prime, I'm going to get negative 6 and 3. Okay, I'll leave you to, just to save a little time. You can obviously plot them. But you apply this scale factor to every term. I think in some classes he wrote, you know, if you start with x, y, and you do a dilation, you end up with the scale factor times x and the scale factor times y. So this is essentially what I did on all those points, but here's a nice little sort of a formula, if you will, where you're applying the scale factor to every point. Okay? It looks like, actually, as I'm looking ahead, it looks like 8 and 9 are the exact same concept, so I'm not going to do all 4 of the same ones. It's the exact same thing. Multiply k, the only difference is the points aren't listed out for you. Right? So you'd have to figure out, you'd have to figure out the coordinates for each of these first, and then apply your scale factor. Okay? All right. I hope that helps. If there's anything else that is on the homework that you're still a little fuzzy about, please just post your questions or email me, and I could either just explain it in words or I can make another video, whatever you need. But this is the last topic to help get you ready for that test. So hopefully it'll be okay for you. All right. Have a good weekend, and hopefully I'll talk to you soon. Bye.